Through this lesson, we are going to look at wind primarily within the first few thousand feet of the surface. We will examine what creates wind, what the forces involved are, and how these change as the wind interacts with its environment, particularly the surface over which it flows. What is wind though? Put simply, it is the motion of air over the surface of the Earth. More particularly though, it is the sustained horizontal flow of air over the Earth. On a large scale, this flow is very closely related to the varying horizontal distribution of pressure, namely high and low pressure zones. The essence of this lesson will look at this relationship in considerable detail. Firstly though, let's examine the measurement of wind and its units. Wind is usually represented as a velocity. Velocity is a vector factor incorporating both direction and magnitude. So, wind velocity gives both wind direction and wind speed. Let's take a look at direction. The direction of movement of any subject is usually given in degrees from north. This scale starts from 0, which is north, all the way through to 360 degrees, which is another way of expressing north. Direction is referred to not as the heading of the wind, but rather where the wind is coming from. For example, a wind blowing towards the east is given a direction from the west, and would therefore be shown as having a direction of 270 degrees. A wind blowing towards the north, in other words, coming from the south, would be shown as having a direction of 180 degrees. Changes in the direction of the wind are expressed using the terms backing and veering. A wind that is veering is changing direction in a clockwise manner. For example, a wind that was 090 degrees and is now 170 degrees would be described as veering. A wind is said to be backing if the direction change of the wind is anti-clockwise. For example, a wind that was 180 degrees and is now 045 degrees would be described as backing. However, we have a true North Pole and a magnetic North Pole. The problem is that these are not in the same geographical location. Traditional meteorology has little concern for magnetic north, and therefore wind direction is referred to true north. However, in flight, headings are referenced to the compass, which uses magnetic north. Most wind direction given by meteorologists will be referenced to true north. When using such wind directions, be careful to adjust them using the relevant variation which allows the calculation of magnetic north. There are rare occasions when the reported winds are given as magnetic wind directions and not true wind directions. These are typically whenever wind is reported by an air traffic controller from a tower and in the recorded aerodrome terminal information service or ATIS. If you remember, wind is reported as a velocity giving both direction and speed. The standard unit of speed is the meter per second. However, this is mainly confined to scientific and theoretical use. More generally, the unit adopted for operational purposes in aviation is the knot. 1 knot is 1 nautical mile per hour. The official ICAO abbreviation for use in aviation is KT. Shown here are the conversion factors between the various units of wind speed. namely knots, meters per second and kilometers per hour. A wind scale to describe. Speed was introduced and devised by Admiral Beaufort for use at sea. An adapted version for use over land is shown here and is often used by meteorological broadcasters today. Measuring wind velocity is quite simple. The most widely used instrument is the Capt generator and wind vane, which is shown here. The three cups capture the wind and, as a result, they will rotate about a spindle. The rotation of the cups drives a sensitive electrical generator. The greater the wind speed, the greater the voltage generated. The generator moves the pointer around a dial graduated in knots. The direction of the wind is measured by remote transmitting wind vane. This simply wants to turn into the wind and offer the least resistance to the airflow. Until recently, these instruments only provided instantaneous readings, but now it is more common for a computer processor to average out readings, usually over a period of 2 to 10 minutes. There is also a requirement to record details of any gusts or lulls in speed. These instruments are used around airfields to calculate the approximate surface wind velocity for aircraft either taking off or landing. The definition of the surface wind is one that blows at approximately 10 meters above ground level. The reason for this is that wind velocity changes dramatically with height and the very near surface velocity can be completely different from that a few meters above the surface. Consequently, these instruments are placed 10 meters above ground level and free of any nearby obstacles that may unduly disturb the flow of air and give misrepresentative readings. On some weather charts you may see wind speed and direction being coded. Shown here are a few examples of how these are presented. Let's take a look at example number 1. The circle denotes the point of observation or the location of the reading. The direction is shown by a straight line coming from the circle. This line points towards the direction from which the wind is blowing. Shown here is a wind from 270 degrees. In other words, a westerly wind. The wind speed coding is attached to the line emanating from the circle. A thin straight line or feather represents 10 knots. A short line or feather represents 5 knots. The triangle shows a speed of 50 knots. In this example we read the speed of 65 knots. Example number 2 shows a southerly wind direction of 180 degrees and a speed of 25 knots. Now that we have learnt some fundamentals about wind, including speed, direction, units and coding, let's examine some specific winds and the forces involved.